Okay, so we're into chapter 11 now. So the last section of chapter 10, the complex numbers, was kind of setting us up here. We've been ignoring negative numbers under the radical, but in this chapter we're going to allow for them in our answers. And this whole chapter is about solving quadratics. So the first solution method is completing the square. So we have two things to look at in this section. The first is how to complete the square and what that means. And the second is just solving quadratic equations. Equations. So we have something called the square root property. And we all know the square root property. We've talked about it before. I don't know if we called it the square root property. But we know if x squared equals 50, for example, we can take the square root of both sides. So we have the square root of x squared equals the square root of 50. We know the square root of x squared equals x. We know the square root of 50 is 5 root 2. And what the square root property says now is we need to account for that negative root. So up until now, we've ignored that negative root when we take square roots. In this chapter and moving forward, we are going to be not only not ignoring them, but they become very important because we know that our quadratics can have two answers, positive and negative. So all of our answers in chapter 11 and going forward will have two answers anytime we take the square root. So why do we care about the square root property? Well, let's say we have a quadratic that looks like this. X squared plus 2x plus 1 equals 0, and we're asked to solve. Well, our first step anytime we're solving a quadratic is to try and factor. So this thing, what multiplies to 1 adds to 2, factors to x plus 1 times x plus 1, or x plus 1 squared equals 0. And so what we do is we square root both sides using the square root property, and we get, that's the wrong color, x plus 1 equals 0, because the square root of 0 is 0. And we have x equals negative 1. And so we're using the square root property. Now, because this was equal to 0, we say that x equals negative 1 because there are two of them. This is what we call a double root. Because it popped up twice. It's a double root. So if we can force all of our quadratics to mimic this process, or we can factor it into a perfect square and square root it, it makes solving really easy. So that's why we have the completing the square method. Completing the square. Because this method is going to turn every quadratic, regardless of whether it factors this way or not, into a problem like this. So given the general quadratic, That is ax squared plus bx plus c equals 0. So we're going to walk through the process of what to do to this quadratic to complete the square. So the first thing we do, number 1, is we divide by a. And so if we divide the general quadratic by a, we end up with x squared plus b over ax plus c over a equals 0. And the purpose of this is to force the coefficient here to be 1. Once we force that coefficient, we isolate the variables. Notice we're saying variables here, so we want to, all we're doing is pushing this constant term to the other side. So we have x squared plus b over a x equals negative c over a. So now we're going to focus on this coefficient here in the next couple steps. So number 3 is to divide b over a by 2. So that's b over a divided by 2. It's always going to be b over 2a. Fourth step is to square that term. B over 2a. And so this is always going to become b squared over 4a squared. And the final step, well, second to last step, is to add b squared over 4a squared to both sides. Of the equation in part 2. Right, so all the way back to this equation. So now we're going to take this thing that we've constructed and add it on both sides. So that's going to give us x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. And the reason we do that is because now our final step is to factor the left side. Because what we've done is we've taken this, we've forced this to be a perfect square. This equals 2 times 1 times this square rooted. So we have forced this term by adding this very specific expression to be a perfect square trinomial. And in fact, it will always factor into x plus b over 2a squared. And this is going to equal b squared minus 4ac over 4a squared. So all I've done here is flip these two and then get a common denominator. So multiply by 4a and 4a. Now we use the quadratic formula, so you may be looking at this and going, this looks very specific or very familiar. Now this is the end of the complete the square process, because now we have a perfect square. We can square root both sides. Using the square root property, that will give us a plus and a minus. Whatever this term is, this will be a number. And then we just subtract the b over 2a over, and we solve. And we'll do examples of that in a few minutes here. But I want to continue on here, setting up the next section. So like I said, this is the end of the complete the square. But if we continue with this simplification, so you can put a line in your notes if you're on the same paper. So if we continue this and we square root both sides, we'll have x plus b over 2a equals the square root of b squared minus 4ac all over 4a squared. And our square root property now says that we need a plus and a minus. So now if I minus b over 2a and I minus b over 2a, I get x equals b over 2a plus or minus the square root b squared minus 4ac, and the square root of 4ac squared is just 2a, and this becomes nothing more than b, negative b, that's what that should have been, negative b plus or minus the square root of b squared minus 4ac all over 2a. So our quadratic formula is nothing more than the end of the complete the square process. So you can think of the quadratic formula as a shortcut for completing the square. It's where it comes from, by completing the square just as we did on the general quadratic, which is kind of interesting because most people don't think of complete the square and quadratic formula as the same thing, but it is. It's why the quadratic formula is so widely appreciated, because it simplifies all that 6-step process that we just did, plus the solving, into one formula, one nice, succinct formula. So we're going to talk more about quadratic formula. I know we've used it before in class already, but we'll talk more about it in the next section. So for now, we need to practice completing the square. Complete the square. We'll do this couple 2-3 times. Let's say we have p squared plus 2p minus 4 equals 0. So the first thing we do, step 1, divide out by a. Well, in this case, a is 1, so we're already there. So we can move on to step 2, adding the 4 over. And we get p squared plus 2p equals 4. And then we take this number here. We do 2 divided by 2. That equals 1. We take that 1 and square it. That equals 1. And then we take p squared plus 2p plus 1 equals 4 plus 1. So you can see we're adding that 1 that we just found to both sides. And now this is a perfect square trinomial. P plus 1 squared equals 5. Square root both sides. And we have p plus 1. According to our square root property, this is plus or minus square root of 5. And so p equals 1 plus square root of 5, and p equals 1 minus the square root of 5. And oftentimes you'll just see this written like this when it can't be simplified. This is a big or here. You can list them both separately, or you can write it as one if it can't be simplified. And the nice thing is, as long as you know what this number is, which is this one, this step is really a formality to make sure you're adding the right number on both sides. So let's take a look at another one. So for this one, we have x squared plus 4x minus 3 equals 0. So again, we already have a 1 here. Dividing by a is 1. So we're just going to add 3 to both sides. X squared plus 4x plus 3, or equals 3, not plus. So take this term, divide by 2, square that, we get 4. So we're going to add that to both sides. So we end up with p squared, not p squared, x squared plus 4x plus 4 equals 3 plus 4. This factors now to x plus 2 quantity squared. And this equals 7. And notice the 2 is this 2. But we square it to know what to add to both sides so that our number here isn't wrong. Square root both sides, and we get x equals, or not x, x plus 2 equals plus or minus the square root of 7. And then we just add that or subtract that 2 over. So we end up with x equals -2 plus or minus the square root of 7. And since this can't be simplified, we can use this as our final answer. Again, you could list it as -2 plus square root of 7 or -2 minus and -2 minus square root of 7. They're both correct versions. Okay. So let's do one more that's not as friendly as these two were. So this would be part C. So we'll do 2x squared minus 8x plus 3 equals 0. So now we actually do have to divide out everything by 2. And that gets us x squared minus 4x plus 3 over 2 equals 0. Subtract this over. So we have x squared minus 4x equals -3/2. We're taking this term again. -4 divided by 2 equals -2. We square that. We get +4. We add that +4 to both sides. Plus 4 here, -3/2 plus 4 here. We've forced this to be a perfect square. X minus 2 squared equals, and this is going to be, what, 4 is 8 over 2. So this is going to be 5/2. Square root both sides. We get x minus 2 equals, our square root property says plus or minus square root of 5/2. Add that 2. We have x equals 2 plus or minus the square root of 5/2. And again, this isn't going to be simplified at all. Now the one thing that might happen, you might rationalize this, or you might want to. So let's look at the two individual cases of our solutions, 2 plus and 2 minus, square root 5 over square root 2, splitting them. So we rationalize by multiplying square root of 2, square root of 2, square root of 2, square root of 2, and then this becomes x equals 2 plus 1/2 square root of 10, and x equals 2 minus 1/2 square root of 10. And then for me, this is a good answer. These are good answers. You could even combine this grouping here as x equals 2 plus or minus 1/2 square root of 10 as well, and that would be a good answer. So on the homework, I don't know if they'll want you to rationalize here. You'll just have to check the little blue writing at the end underneath your answer box. but this is how we complete the square. Sometimes it's nicer than others. This time was not as nice as the first two. Sometimes it's really easy, sometimes it's not. We do need to know how to complete the square. So please don't just say, I know the quadratic formula, I can solve all these with the quadratic formula. Because you may be asked to complete the square and you have to do that. So that's the end of 11.1.